Hello, my name is Antti Hyttinen, and in this video I'll present you Taylor's room disinfection solutions based on blue LED light and catalytic coating treatments. We're going to go through Taylor's background in brief, take a look at the studies and cost of infections in the hospital sector, and introduce you to the scientific properties and benefits of blue light disinfection systems, introduce you to our product portfolio, and take a look at the effects of catalytic coating as a part of the disinfection system. Then we'll calculate some payback times for the system and take a look at some reference cases and wrap it up in the end. So the background of the company, we've started in 2014. After years of extensive research and testing, we launched our blue light based disinfection systems a few years ago. And in the core of our business is the research and development that we are doing in the field of potent disinfection. As our lead scientist, we have Camilla Höglund. She's been doing research for the University of Helsinki for more than 10 years already, and for more than half a decade she's been studying or researching optogenetics, which is the science studying the effects of light on living organisms. She's writing her PhD for the Faculty of Medicine at the University of Helsinki at the moment, so we'll soon have our own doctor in-house. So just to assure you that we have a lot of expertise in this field, and we are happy to support you in more deeper discussions in the research done on this topic, or if your customers want to hear more about the tests conducted with our products. We have plenty of those also, and we'll take a look at them during this presentation. So what we're doing is chemical-free, safe and automatic disinfection of complete rooms. We also have solutions for equipment disinfection, but in this video we'll be focusing on room disinfection solutions. These kind of systems are already being used in many kinds of environments, mainly in the healthcare sector. So we have plenty of customers using our products in operating rooms, for example, in hospitals. We have nursing home customers using our systems in their toilets, daycare centers, dentist practices, many kinds of environments. But it's also really useful for bringing this kind of hospital level hygiene with this kind of automatic system into other environments also. For example, industrial clean room environments or other kind of commercial environments where there is a need to improve the level of hygiene. And the system is based on blue LED light combined with a photocatalytic treatment on the surfaces of the room. The idea with this kind of system is to automatically disinfect all the frequently touched surfaces in the room, and in all kinds of environments there are plenty of such as all the countertops that you're working around, door handles that everyone has to touch, and therefore they pose quite a potential area of cross-contamination. In toilets there are flush buttons and faucets when you're washing your hands. So when you think about it, there is a lot of areas that everyone has to touch, and this always poses a risk of transmitting microbes from one person to another. And the problem with this kind of cross-contamination is that microbes are able to survive on surfaces surprisingly long periods of time. So depending on the type of microbes, there are some microbes that are only able to survive for a few hours or a couple of days. Others are able to survive even for weeks. For example, norovirus is quite a known example of such a problematic virus, that it's really pathogenic even for weeks on a clean surface. But there are even some microbes that are able to survive on surfaces for several months. So if these surfaces are not disinfected, there will be a risk of getting contaminated even for weeks and months. So that's why surface disinfection is conducted in any environment. Regarding coronavirus, the time is, depending on the surface, around 1 to 2 weeks it's able to survive pathogenic. So disinfecting this kind of frequently touched surfaces is critical to maintain a high level of hygiene and to prevent the transfer of these microbes from one person to another. And taking care of the hygiene to prevent this kind of infections, it's crucial for improving the safety of not only the workers or care personnel working in that environment, but if it's a healthcare environment, also for the patients and to protect them from infections, or in other commercial areas, or for example laboratory environment, it's also to protect the quality of the products manufactured in those premises. For example, in the healthcare sector, it's not only human suffering that is caused by these infections, but there is also economic losses, which are quite major. Only in Europe, according to ECDC, on any given day, there are more than 80,000 patients in the acute care suffering at least one hospital-acquired infection. Not only these general healthcare-associated infections, but among the most problematic ones are the surgical site infections, which cause the biggest problems and biggest losses monetary. So for normal general healthcare-associated infections, on average, the cost for treating is around 10,000 euros per infection, just one single infection. That is because of a prolonged treatment time, generally on average 1 week longer than a non-infected patient. But when talking about the surgical site infections, meaning infections acquired inside the operating room during a surgery, if it's an implant-associated infection, the cost is count in hundreds of thousands of euros per one infection. And preventing these kind of infections has been tested with this kind of blue light disinfection systems. For example, in this case study from USA, the influence of a blue light disinfection system was monitored in an orthopedic operating room. So they installed a blue light disinfection system into an operating room and monitored the amount of infections and also the amount of surface microbes for a period of 1 year before installing the blue light system and 1 year after installing the blue light system. And what they found out in this test or this research was that there was a significant reduction in the microbial levels on the surfaces of these operating rooms equipped with the blue light system. So from 49 to 81% reduction in microbial amounts. Also, that led to less infections in these operating rooms. So the money or the amount of money saved in this one operating room installation is calculated in millions of dollars per year. So as you can see in this chart in the slide, the amount of surgeries done during the test period, so 1 year before and 1 year after the installation of blue lights, the amount of surgeries was quite similar before and after, but the amount of infections in those operating rooms was more than 70% less. Of course, the numbers are still quite small, so there was only single cases of infections before and after, but still, because the cost of each infection is hundreds of thousands of dollars, the savings were quite huge. And to compare, there was another operating room also included in this monitoring, and that operating room was left untouched. There was no blue light system installed, and that served as a control environment to see if there was change in the amounts of infections for some other reason. But in the operating room that was not installed with the blue light system, there was no reduction in the amount of infections. So this gives quite a good indication that by using this kind of automatic blue light disinfection system in your operating room to automatically disinfect the surfaces every night, it not only reduces the colony forming units, the microbial amounts on the surfaces, but it also seems to lead into less infections in this kind of environment. This is the first study from a real-life environment in an actual operating room. So there is not that much of experience from this kind of installations yet, but it is a really good indication of a real-life effects of using this kind of system. In this review article, they researched how effectively premises are disinfected at the moment when using this kind of traditional methods. And there is quite a good indication that using traditional labor-based and chemical-based disinfection is not really performing as one might think. So what they found out is that in many facilities only 40 to 50% of the surfaces that should be cleaned are actually wiped by housekeepers. And this is quite understandable when you think that the schedules of the personnel doing the cleaning are constantly being tightened, and of course it's a money question that you need to do your work faster and faster to be more productive. And naturally, when we are talking about human labor, this usually leads to a less quality performance. And there are also other human factors when talking about manual cleaning. So you always have to make sure that you have proper processes for making sure that your equipment that you're doing the manual cleaning are properly maintained and of high quality. And this kind of problems have also been found out that there can be contamination even of the equipment used. But to conclude the findings of this research, they give quite a good statement that with the blue background in the low left corner. So, given the many challenges in achieving desired levels of surface disinfection, adoption of modern technologies is indicated to supplement traditional methods. So, this also indicates that there is a need for better and more reliable methods of disinfection than just relying on human labor and the performance of individual housekeepers. And this is what we are providing. We are providing automatic systems that constantly provide good disinfection results. And not only this, we are providing ecological method. It's a chemical-free solution that we are offering. We are making the disinfection completely automatic. So there is no manual labor, there is no human factor. You can improve the level of hygiene without acquiring more personnel or learning new ways of working. Our system is completely safe. There is no UV radiation, it's visible blue light only. And of course, when there's less chemicals, there is less risks of health for the workers. All of our products are based on LED technology, so when it's LED components, the lifetime of all of our products is at least 10 years. We are also providing a maintenance-free solution, so for 10 years the system is installed and for the next 10 years it's completely maintenance-free. It's easy to use, there is no training needed for the personnel, and it's also been tested by the authorities that the radiation of our products is non-ionizing, meaning that it's not causing damage to the materials in the room. And also blue light has been studied for the antimicrobial resistance, and such mechanisms have not been found out, and it is unlikely that such mechanisms would occur. So why now, one might ask? Basically, the breakthrough of blue light disinfection is happening now because of the development of the components. So the antimicrobial effects of blue light have been known for several decades already, and it has been studied with the traditional light sources, for example fluorescent tubes or incandescent bulbs or other white light sources. And as we know, white light it contains all the different wavelengths of light, meaning that is all the different colors are combined, you get white light. And if you want to study some specific wavelengths, for example, you want to see only the blue light from this kind of traditional white light source, you need to filter out all the unwanted wavelengths so that only the blue light passes through. And with this kind of filtration, you can study the effects of the blue light. So the antimicrobial properties have been known for a long time already, but only for half a decade it's been possible to produce high intensity blue light energy efficiently and cost efficiently directly from the component by using this new kind of blue LED components. So that's why we are now bringing this technology into real life environments. But since the mechanisms have been studied for decades already, the effects and the mechanisms behind are well known. At the moment there's roughly 2,000 scientific studies published that are studying or have studied the antimicrobial properties of blue light. The basic mechanism is shown in the picture on the left. So, as you can see, there's a bacterial cell demonstrated in the picture, and inside the bacterial cell there are some proteins that absorb some specific wavelengths of blue light. And when we increase the intensity of the blue light into a high enough level, the energy of the blue light is absorbed inside the bacteria, and the metabolism of the microbe is accelerated, and this starts a chemical reaction where reactive oxygen species are formed inside of the bacteria. So these reactive oxygen species start causing damage with several mechanisms inside the bacteria. And basically these reactive oxygen species are different kinds of peroxides that are also used in traditional chemical disinfection. In the traditional method, these peroxides are poured on the microbe, and the microbe is attacked with these peroxides from the outside. But in our blue light system, these peroxides are just formed inside of the microbe with the blue light, and this causes the microbe to die. The mechanism is a little bit different from the mechanism of UVC, of which some might be more familiar with. When disinfecting with UVC, the energy of UVC radiation, it penetrates the cell membrane and it causes direct DNA damage inside the microbe. This is why UVC is a little bit faster than blue light, but this is also why UVC is much more harmful for people. So UVC also penetrates our cell membrane and it causes direct DNA damage for humans. This is why you should never be irradiated with UVC. It will cause damage to your skin and especially to your eyes. Whereas blue light has been tested, and we have even tested our blue light products according to EN standards for the safety hazards for human eye, and in normal conditions there is no safety hazards with our products. And also we've tested our blue light products at the Radiation and Nuclear Safety Authority of Finland, and we have a report from them saying that it's non-ionizing, meaning that our blue light does not harm surface materials either. Whereas you might know that with traditional UVC tubes, for example, it is inevitable that these, especially plastic materials, will be damaged and will degrade during time. But that's one benefit for our blue light system: no damage to materials and also completely harmless for people. Biofilm is one interesting area. So with the traditional methods using chemicals, it's really difficult to penetrate the biofilm and effectively kill microbes on a surface. And the biofilm, in brief, it's a protective layer that microbes form around themselves to protect them from outer threats. And this protective film that they create during time makes it more difficult to destroy them with traditional means. But there are studies where blue light has been tested with, for example, MRSA microbes, bacteria, as a separate bacteria, and also on MRSA protected by biofilm. And the research shows that blue light is also able to penetrate the biofilm and inactivate the bacteria through the biofilm. So again, even more comprehensive disinfection results with blue light than with traditional methods. Here you can see the complete photon disinfection system. So when the room is occupied, the white light is on as it was before, but once the room is unoccupied, when people leave the room, the presence detectors automatically engage the blue light disinfection and the room starts disinfecting itself. Blue light on itself destroys bacteria, yeast and mold from air and surfaces of the room. And to boost the disinfection effect, to also affect viruses and odors and harmful volatile organic compounds in the room, we use the catalytic coating on the surfaces of the room. So basically these two parts make the disinfection system. Simple as that. We have several different versions of our products. We have the panel light, which can provide both the white general light and also the blue disinfection light in the same luminaire frame. We have some general blue light products that you can easily add the disinfection into an existing room. If you already have the white light, you only need to add the blue light product to disinfect the room when it's unoccupied. And we also have the mobile unit that can easily provide disinfection into areas where the need for disinfection is only temporarily, or you want to have a more economic solution to provide disinfection into several areas with one mobile unit. Then we have some smaller units for smaller rooms, for example toilets. We have the line profile luminaire that can easily provide the disinfection into a toilet, for example. And then we have the round down light luminaire, which also includes both the white general light and the blue disinfection light in one luminaire frame. Here you can see results from a test conducted with our blue light products. The test was done at Turku University of Applied Sciences in Finland, and it was a laboratory test on these agar plates. The test microbe was E. coli, which is the most common cause of hospital-acquired infections in all Europe. So it's a really relevant bacteria for us. And the intensity of blue light was really moderate on this test. Usually when we are calculating solutions to our projects, there is at least this intensity on all critical areas, usually even much more. But this gives quite clear indication of the efficiency of our system. So as you can see already on 2 hours, after 2 hours, roughly 90% reduction, and after 6 hours when the test ended, over 3 logarithm reduction, so more than 99.9% reduction on microbe amounts. And it's good to take notice that there is also the control sample in this test. So in all of our tests, our lead scientist Camilla is doing really comprehensive testing, and it's always important to have these control samples to show what happens to this exact microbe in that test period without the effect of the blue light. So there is always some natural reduction also, and it's important to indicate that natural reduction also. And as you can see in the graphics, there's roughly 20% reduction naturally, even without the blue light. But still quite a big difference already after 2 hours, 90% reduction with the blue light. And there was 3 parallel samples and 3 test rounds in this study. And the effects of blue light have been tested all over the world with many microbes. So it is commonly known that it is effective on all kinds of bacteria, mold and yeast, because all of these bacteria, mold and yeast, they have the same kind of metabolism products where the blue light affects. And in this chart you can see we have compiled a list of the most common causes of hospital-acquired infections in Europe. So the list is based on a list from ECDC, and these are the most common causes of HAIs in Europe. And as you can see on the top left, E. coli, it represents more than 15% of all HAIs in Europe. The second most common is Staphylococcus aureus, and there are plenty of others also. And we have compiled a reference on a study where they have tested blue light on all of these microbes. So you can see on the reference graph there are several studies testing these different microbes. So the effects of blue light have been proven on all kinds of bacteria. But when it's not only about bacteria, when you're also interested in destroying viruses, that's where we need something more than just blue light. So that's when we implement the use of catalytic coating. So it is based on a photocatalytic reaction. So phenomenon is called photocatalysis, and the energy of light triggers a chemical reaction on these catalytic coatings. And the coating that we are using, it is based on titanium dioxide, and with this combination of blue light and the catalytic coating, we can provide a more comprehensive solution that is also effective on viruses. Here you can see on the left side the benefits of combining these two is the efficiency against viruses and also against spores, because these two kinds of microbes, they don't have a metabolism, so blue light is not effective on them. But the combination of blue light and catalytic coating is effective on them too. On the right side you can see that blue light, even without the catalytic coating, is effective on biofilm, all kinds of mold, yeast and fungi, all bacteria, whether it's gram-negative or gram-positive, and all kinds of bacteria, mold, yeast and fungi. The basic mechanism of how this combination is effective on viruses and spores. Here you can see when we have a surface treated with the catalytic coating, when it receives high enough intensity of a suitable wavelength light, what happens is the energy of this light triggers a chemical reaction where the energy of light transforms into a chemical substances, reactive oxygen species again. And these reactive oxygen species are formed on the surface of the coating, and they react with anything in contact with the surface. So if there is microbes, viruses, VOCs, it breaks them down, these peroxides break down them into smaller molecules, eventually leading into water and carbon dioxide. If there is not microbes on the surface, the reactive oxygen species are really reactive, and they react with air and break down. So we are not filling the room with this kind of reactive oxygen species. but they just form on the surface and break down and destroy any organic matter if such is on the surface. So this way we can provide a really comprehensive disinfection result into the room when the blue light on itself already destroys the bacteria, mold and yeast on top, and also the photocatalytic reaction forms these reactive oxygen species and boosts the effect. And this combination we have also tested several times. Here's an example of a laboratory test from 2019. So this test was conducted at the Finnish accredited Metropoly Lab. So this is the highest accreditation level that you can achieve in Finland, so that all the methods of working and the standards that they are working with are top grade. And in this test, the test microbe was Staphylococcus aureus. As you might remember from the slide before, the second most common cause of hospital-acquired infections in Europe. So really relevant bacteria again. And in this test, we tried to simulate the real-life environment as well as possible. So this was not a culture plate test, but instead they had a melamine table surface. Half of the table was coated with the catalytic coating, half of the table was not, and the microbes were spread on the table surface, and there was blue light installed into the room. And then they started taking samples every 2 hours to see what are the amounts of microbes on the surface. And from the graph you can see that on the coated surface we achieved the level of disinfection already in 2 hours that we were able to achieve with the blue light only. So it really boosts the effect of the blue light quite well. And in 8 hours with this kind of low intensity of blue light, we achieved more than 99.9% reduction in microbe amounts. Here's another test done with our products from 2020, again at the same Metropoly Lab test facilities. And this time the microbe test bacteria was E. coli, the most common cause of hospital-acquired infections. And the microbes were spread at the bottom of a plastic petri dish, no agar, but just the clean plastic petri dish. And again, the same low intensity of blue light in the room. And half of the petri dishes were plated or coated with the catalytic coating, and half of them were not. And in the graph you can see the difference and the reductions. So the reduction on this E. coli seems to be quite a lot faster than in the previous test. So MRSA was a little bit more difficult to inactivate than E. coli. But here you can see that already after half an hour we achieved 99% reduction on the coated surfaces. Even without the coating, we achieved similar results in 4 hours. So quite significant results. In 2 hours on coated surfaces, over 3 logarithm reduction, 99.9%. And again, you can see the control samples, meaning the samples that were in the same room, same office conditions, but covered, protected from the blue light, so that you can see the natural reduction of that microbe. So here you can see the basic idea of our system. Always when a room is occupied and people are working in a room, they bring more microbes and contaminate the surfaces as they touch the surfaces. At some point, usually a manual cleaning is performed, depending on the site, once a day or once a week. But when the cleaning personnel do their job, disinfect the surfaces, the amount of microbes is minimized, but it is always depending on how accurately the cleaning personnel do their job. So the disinfection result may be uneven, and it is always affected by human factor. The frequency of disinfection stays the same. It is quite low, once a day or once a week. And in between those times, the microbe levels only increase. But when we implement our system into these premises, the automatic system provides a constant reduction of microbial levels. Every time when the room is empty, blue lights switch on and start disinfecting the surfaces and reducing the amount of microbes on the surfaces. It might not deliver 100% disinfection right away on their first startup. So if someone comes into the room and interferes with the disinfection, the blue lights switch off, people bring more microbes into the room. But again, when the room is empty, immediately the blue lights start doing the disinfection job. And this provides a constant reduction. We are taking advantage of all the moments when the room is unoccupied and decreasing the microbial levels. So now it is not only once a day or once a week when the disinfection is performed, but instead every time when the room is empty. Therefore, this kind of automation leaves out the human factor. It's no longer depending on how accurately someone does their job. Instead, you can always rely that blue light always reaches the surfaces as accurately as it did yesterday, and it's always diligently doing its job when the room is unoccupied. So the frequency of disinfection is increased dramatically every time when the room is empty. This will lead into lower average microbial amounts in the premises. So to calculate the payback time for our system, we are using this hospital toilet as an example. Toilets generally are a really good area for using photon disinfection because in toilets there are usually quite a lot of microbes out of natural reasons. And there are many critical, frequently touched surfaces that all the users of toilets have to touch. You have to touch the doorknob when you enter and leave, the toilet flush button, and the faucet when you're washing your hands. So to implement our system into this toilet, we need a few of our disinfection luminaires and the catalytic coating treatment on the surfaces. So for this kind of 10 square meter toilet with a couple of booths and a washing area, we are estimating a cost of 4,000 euros. And to take that into a real environment in a real hospital, this is a list of all hospital-acquired infections and the costs generated by them in Turku University Hospital in Finland. So this is a list and calculations of costs provided by the hospital. These are their actual costs that they are announcing by themselves. And generally, more than half of all healthcare-associated infections are estimated that they could be prevented. So if we calculate that this hospital would install our system into all of their toilets, 125 toilets to cover all of the hospital area, with a 4,000 euro investment, it would lead into €500,000 investment. So by just preventing 5% of their total of 10 million euros spent in these infections every year, we would generate a payback time of less than 1 year. Because 5% of the 10 million euro cost in the infection prevention, it's already more than 500,000 euros. And the lifetime of our system is more than 10 years. So during the 11-year lifetime in this environment, we would generate savings of more than 5 million euros by just preventing 5% of all of the hospital-acquired infections in their hospital. Even if we weren't as optimistic of estimating that we could prevent 5%, let's say we only prevent 1% of these infections, we would still have a payback time of less than 5 years, and during the lifetime of 11 years for the system, the lifetime savings would be more than 650,000 euros. So it is definitely a good investment to invest in infection prevention. And as we saw in the example in the beginning, these kind of savings have already been proven in real life environment, as it was in the operating room example from United States. To offer a photon disinfection system, we need some basic information. The dimensions of the room, including the height of the room, and time available for using the blue light on average per day. Based on this information, we can calculate the amount of blue light luminaires needed and the cost for the catalytic coating, and solve the problem of the customer. And just to make you think a little bit about the consequences of the problems that we are solving. In which hospital would you rather be? Think to yourself. Would you feel better if you knew that there is automatic system to disinfect the surfaces in your hospital?